Hello, my name is Paul Bemis, and I'm the president of Air Cleaners, Inc. Today, we're going to talk about how to rapidly reduce airborne pathogens in indoor spaces and the associated risk of airborne disease transmission. Let me begin by introducing you to our clean air curtain design. It begins with a high-pressure blower, in fact, the same type of blower used in high-performance data center designs. We then added a true HEPA filter that is placed inside the unit to trap contaminants down well below zero point 0.1 microns in size. We then added a UV light to kill pathogens as they pass through the device. The clean air curtain is shown here in this CAD illustration. Air comes from both sides of the unit and exits from the top in a very high-speed outlet plume. The device is fairly small, measuring 24 inches wide by 12 inches deep by 8 inches high, making it something that can be placed on a tabletop or a desktop, closer to the human breathing zone. This is a CFD output image illustrating the interior flow dynamics of the clean air curtain. For those of you who don't know what CFD stands for, it is computational fluid dynamics and is a mechanism used in the aerospace and automotive markets to model the behavior of fluid flow phenomena. In this case, it allows for the visualization of air as it passes through the unit. The air is represented in this image as path lines coming through the return plenum, then traveling down this high-speed blower where it gets pressurized and then driven underneath the large HEPA filter. The HEPA filter is 3.5 inches thick and is a true HEPA filter, the same type used in semiconductor clean rooms or surgical operating rooms. Perfectly clean air is then exhausted out into the room through a long, narrow slit in the top of the device, which is 1/2 inch wide and 17 inches long. You can see the speed of this in this illustration operating at 1,300 feet per minute. However, in practice, we have measured this unit actually operates at 2,500 feet per minute of exit velocity. This enables the device to rapidly reduce any kind of pathogen in the environment, as you will see. This is an illustration of what is called a velocity contour, showing velocity as a function of color. We're watching the air exit at very high speed and continue well up into the room. This rapid airflow induces the rest of the air in the room to move as well, and because the exhaust air consists of the cleanest air humanly possible, it dilutes any and all pathogen concentrations that might be present in the room. We have measured this in our laboratory, producing velocities of over 300 feet per minute at a height of 15 feet. This is a side view of the same device. You can see the creation of the air curtain, which is how the device got its name. It creates a curtain of air straight up into the room, inducing the rest of the air in the room to move as well. On the right-hand side, you can see that it moves in a clockwise direction, and on the left-hand side, you can see it moves in a counterclockwise direction. This is called induction. It is inducing the rest of the air in the room to move and will therefore drive down pathogen concentrations located anywhere in the volume of the room. Now let's take a look at how the clean air curtain performs in a room. We've taken the device and again, using computational fluid dynamics, put it into a room that is uniformly infected with a pathogen. As you can see, we've placed the unit in the middle of the room, up off the floor at about 4 feet. It's best to have the device centrally located if possible, and up off the floor. It is not imperative that they be centrally located, but best if possible. This room is a 15 by 20 foot room with a 10-foot ceiling, representing about 3,000 cubic feet of volume, indicative of a meeting room or a classroom. To model the clean air curtain, we have used the exact dimensions of the unit, including the slit at the top, which is 17 inches by 1/2 inch wide. The initial viral load conditions were set at 100 particles per kilogram of concentration in the room and is representative of any pathogen, such as the SARS-CoV-2 pathogen which causes COVID-19. So let's see what happens. The plot that I'm about to show you illustrates the decay and the contamination level inside the room as a function of time. After 2 hours, the steady-state condition for the room will be achieved. However, it is important to note that we do not need to clean the air to make it equivalent to a semiconductor clean room, but rather just reduce the viral load down low enough so that it does not trigger the infection in our respiratory system. The y-axis records the viral load in the room, and the x-axis records time. The first thing to observe is the rate at which the clean air curtain reduces the concentration of viral load in the room. You'll notice looking at this plot that just after 20 minutes there is a 60% reduction in concentration of the viral load in this room, and within 30 minutes there's an 80% reduction. So just to highlight this point again, the clean air curtain reduces the concentration of the viral load in this completely contaminated room by 80% in 30 minutes. It is just incredible how fast this device drives down airborne contaminants. This is a result of the high-speed, clean air exhaust driving down the concentration of the room and is unique to only this design. There are no other air purifiers in the market that will have this kind of effect on a room of this size. By taking a look at, again with the CFD velocity contour plot, we can see the plume being injected vertically into the room. The high velocity clean air is coming out of the top of the device and bouncing off the ceiling of the room. This is a pathline plot on the right, which traces the path of air particles through the room, and as you can see, the air bounces off the ceiling of the room and induces the air to move in a clockwise direction on one side of the unit and a counterclockwise direction on the other side of the unit. We can look at this as a vector plot as well. A vector plot shows this image representing the magnitude and direction of the resulting flow in the room. The air is rotating on this side in a clockwise direction and on the other side in a counterclockwise direction. This is another view of it on the right with the results rotated 90 degrees. And we can see again that on either side of the device, it creates a clockwise direction on one side and a counterclockwise direction on the other. So now let's look at the performance of the cleaning ability of the unit as a function of time using pathline plots where red represents the maximum viral load concentration in the room and blue represents a perfectly clean environment. This is the initial state at time equals 0 when the contamination is the highest and we've just switched on the clean air curtain. Within the first 5 minutes, we see a 25% reduction of pathogen concentration in the entire room. This alone may be sufficient enough to suppress the transmission of COVID, but it continues, and within 20 minutes, it has reduced the viral load of the concentration by 63% in the entire room. In 50 minutes, there's only 8% of the initial viral load left in the room, and the solution becomes steady state in 125 minutes with 99.8% elimination of all pathogens in the room. This is an animation sequence that shows how that looks as a function of time. We've taken all the various plots and put them together in an animated sequence. This sequence takes place over a 125-minute period, and as you can see, the concentration drops very, very rapidly and then finally just completely being eliminated from the room. So in summary, the clean air curtain not only produces the cleanest air humanly possible, but the exhaust plume created by the device induces the surrounding air to move, thereby diluting any viral load present in the room. The unique design of the clean air curtain makes it the most effective device in the industry for reducing the risk of airborne pathogen transmission that we have seen. And the clean air curtain is equally effective against all forms of airborne pathogens, as well as pollen, dust, and any other contaminant in the room that would cause human health problems. For more information, please reach out to us at aircleanersinc.com. This is Paul Bemis, President of Air Cleaners Inc., and I thank you today for your time.